hopefully you've seen some lessons where I've assigned and that you are looking at scientific notation. Your quiz from yesterday, I'm in the process of grading. I probably won't get it done sometime today. I'm subbing a little later. So if you would please right now just take a look at these numbers. Now, I would like you really quickly to do these calculations that you are looking at. 9.2 times 10 times 100 times 1,000. 8,730 divide by 10, divide by 100, divide by 1,000, and give me those answers. As we look at scientific notation, as I'm talking, you're going to do those right now. Start writing your answers. Like the first one, pretty easy. It's what? 92. Keep going. Do the rest of them, please. So we're going to understand the system of scientific notation. We know that that's from in science that you've started working with really large and really small quantities. Okay? So today we're going to kind of be developing that. We're going to look at both lessons 7 and 8 today. So if I was writing in my answers as I am taking a look at this, hopefully yours were very similar. The next one should be, if we are looking at it, 920. The third one, as I am taking a look at that, 9.2 times 1,000 should give me 9,200. When I'm dividing by 10, I should have had 873. I should have had 87.3, and the last one, hopefully, and maybe you did it using your calculator or not, was 8.73. And it says there's always a shortcut that we can think of when we are multiplying or dividing by 10. So when you multiply by 10, so please write multiply by multiples of 10. What would you say are rulers? We are moving the decimal point in which direction? We are moving the decimal point to the right. Yeah. Right. And so when we are taking a look at this, when we multiply by multiples of 10, we are going to move the decimal. How do we know how many times to move it? We're going to move that decimal point to the right. But what determines how many places I should move it? If I only move it one place, if I move it 2, if I move it 3. By looking at the what? The number of zeros. When I'm thinking about the power of 10, right? Of the 10. So when I multiplied by 10, I moved it one place. When I multiplied by 100, 2 zeros, I moved it 2 places. Multiplied by 1,000, we moved it 3 places. Okay? So the shortcut when we are thinking about this, if we are dividing, when we divide by a multiple of 10, what's the only thing that's going to be different? If we are thinking about that. If we think of our decimal point being back here, we got 873, we moved it one place. Here we're moving it 2 places. Andrew, you got to pay attention. If it doesn't work to sit there, we can move. And if we're looking at this one, we're going to move it 3 places, right? Because I have 3 zeros. So the only thing different about dividing is now we are going to move the decimal to the left. How do we know how many places? If it's 10, we move it 1 place to the left. If it's 100, we are going to move it back 2 places to the left. If it's 1,000, wherever that decimal point starts, we're moving it 3 places back because we have 3 zeros that we are looking at. Okay? So make sure you have that. Lots of ways to write numbers. For example, we've seen Roman numerals, if you work with those. Today we're going to look at other forms. Decimal notation, or called standard form. What I would like you to write down for that, that is when we have the regular way of writing numbers. This is kind of what you're used to seeing. 2,507, 58.23. You're filling that in that box right there. Start writing. It'd be easier if you start writing so this is just regularly how we write our numbers. Whereas scientific notation, and I know you started talking about this with Ms. Friends in Science, with our large and small numbers. Scientific notation is when you have a number that's greater or equal to 1 and less than 10 times a power of 10. So please make sure in those 2 boxes in your notes that you fill these 2 things in. The regular way of writing numbers, give your examples. Scientific notation. Key thing, this number is between 1 to 10. It will never be 10, it could be 1. So it's going to be between 1 and less than 10. So notice it says greater or equal to 1 and less than 10 times 10 to a power. When our power, as you are taking a look at this, when this power is a positive number, you're going to have a big number, bigger than 1. When it is a negative number, this is telling us we're going to have a decimal. It doesn't tell us we have a negative number. It tells us that my answer is going to be a small number. So please circle the negative and put small number. If I would write it in standard form, it would be a small number like a decimal between 1 and 10, or between 0 and 1, between 0 to 1. When I have this power being greater than 1, this is telling me that my number is going to be a larger number, and when I mean larger, I'm pretty much talking about that it's just going to be greater than 1. So scientific notation, again, like I said, we probably talked about this a little bit in science as you are looking at that table. First number, greater or equal to 1, less than 10. We are usually going to use that x for our times 10 raised to an integer, always base of 10. So if we have 5,326.2 as a number, if I'm going to write it in scientific notation, so that's what you're going to be asked to do today. First thing we have to do is decide how many places we have to get a number between 1 and 10. So we move our decimal back 1, 2, 3 places so that it's between the 5 and the 3. That means this is going to be power of 3 because we moved our decimal back 3 places. Okay? So when you take a look at that, if I would take and multiply this on my calculator, I would get this same answer. So 10 to the third, remember that is like 1,000. Top of the next page. We are looking at converting. When you are asked to convert, scientific notation is all about finding the number between 1 and 10 and then counting the number of decimal places that we need to move it. So we're given this pretty big number. Should my exponent be positive or negative? Big number. Positive. 52,400,000 converting. So we are going to start, first thing, we only want to look at the digits to the left of the decimal point, which is we want to get it to be a number between 1 and 10. So if we are looking at that, a number between 1 and 10, I have to go 5.24. We are not going to write all the zeros behind that. And now I have to count how many places did I move it from back here. I went 3, 6, 7. So when I take a look at that answer, as I am looking at this, my solution should be 5.24 times 10 to the 7. Make sure, since this had no label behind it, you don't have to put a label. The next one, I have a really small number, which means my exponent has to be negative. I have to get a number between 1 and 10, so I go 1.2. How many places do I have to move my decimal point? And here's a really cool thing about those negatives. How many zeros do you have in front of the 1, 2? We have 5. That's going to tell us our exponent in scientific notation. When I'm looking at a number, I want to count the number of zeros. That's kind of my hint because there's one in front of the 0 plus the rest of them, which meant I had to move it 5 places. So now I want to take a look at this last one, and it says 300 as we are looking at that, 300 million, if we are looking at that, meters per second. So 3 times, how many places are we moving our decimal? 3, 6, 8 places. So we can't count the zeros necessarily always when we are moving with a larger one, but when it's a small number, we can count those zeros. So make sure you have those written in. Now we're going to convert as we look at the next ones on the bottom half of the page. So make sure you have all 3 of those. Some of you don't have that last one, 3 times 10 to the 8. We want to keep the label with it. Okay. Now on the bottom, okay, so we're down here. So now as we are working on the bottom of this page, now we want to convert them to from scientific to standard form. So converting scientific notation, it says, as we thing is to know what the exponent is telling us. How many decimal places do we have to move? Don't count the zeros. That is key right here. It is not about counting the zeros. This is the biggest mistake that all of people make. This does not mean add 5 zeros. In scientific notation, it's telling us, because it's 5, that we have to have a big number. So when I look at the big number, that means that I need to move my decimal point over 5 places this way, which after I go 805, how many zeros am I looking at? 2. So when you look at yours, this should be 803, 805, right? So we have the 3, 805 with 2 zeros, okay? We moved the decimal over 5 places. Now, when we think of this number and converting it scientific notation, it's a really small number. What we want to be thinking of is how many places do I have to move my decimal? I have to move it 6 places to the left. This is, when it's negative, you almost, not necessarily, but you're kind of counting the zeros. You should have 0 point. And then when I take a look at this, I have 5 zeros here, but I have a total of 6 zeros, if I'm looking at that. So when I have this really small number, I am moving the decimal over 6 places. One, starting from here, gives me 1, 2, 3, 4, 5, 6. 6 total zeros when I go smaller. The 1 in front plus the 5 behind. Okay, so we're kind of taking a look at those. As I take a look at that next one, I want you to try writing that one. We are looking at it, right? Did we have 7 zeros behind it? Why 7 zeros behind this one and not 5 zeros up here? Why not 5 zeros? Brad, what do you think?
Because
the number after the decimal was a 0, so which means we are going to have, in this case, 7 zeros. Whereas here, we had 3 numbers behind, so we can't put 3805 with 5 zeros. You have to look at what's behind the decimal. So you got to be kind of careful when you look at those. Okay? So here's some really big numbers. We're going to practice writing them in scientific notation. So as you are taking a look at your notes, as we look at that first one, where do I want to place my decimal point? It should be 7.3. Count those zeros, right? So how many places? And what's nice is ours number system puts them in groups of 3, right? So 3, 6, 9, 12, 15, 18, 20, 21. Huge number times 10 to the 21. Please make sure you write kilograms. Oh, here. Again, notice we put them in groups of 3, which means it's going to be times 10 to a negative power. Count the zeros. Start counting. The first number, 9.10938, 10 to the negative 31, and then we want to put our label kilogram. Okay? As you are taking a look at the last one, decimal has to be between the 2 and the 9. 3, 6, 7, 8. As you are taking a look at that answer, times 10 to the 8, and we need to put all of those. Now, one of the things that I will do is I'll ask you to round this, because usually if it's in scientific notation, it's a huge number. This is the answer that I would look for. Now, instead of putting 2.99, we probably round it to what? 3 times 10 to the 8. Because isn't this almost 300 million, right? So putting that number down, writing it like this might not make sense if we're talking about how fast that is, if we are looking at it. 1,236, keeping the label kilometers per hour. The next one's going to be small. Doesn't mean, remember, this didn't mean 3 zeros, it means moved it 3 places, which is right at the back of that 6. This one tells us move it 5 places, which means I should have the first 0, and then how many more? No. I should have a total of 5 zeros when I look at this one. I had -5 if I am looking at that. That tells me to start here and move it 5 places. That's 1, 2, 3, 4, 5. If it helps to draw and put these little like squiggly arcs or whatever below it to show where you're moving it, put that down. If that helps you, write it down. So try the last one. Talk to your shoulder partner. Less or greater than 1? Greater than 1. So that's your homework tonight. They're going to ask you, is it less than 1 or greater? And to write it. In this case, if I'm looking at it, someone want to raise their hand and tell me what they got? Maddox, what'd you have? 475,000, and then put your label meter. So this one is adding 3 zeros behind it, right? Because you moved it 3 places, and you need to move it 6, so a total of, if we are looking at that, okay? If you don't have a calculator, we are going to be using calculators with this part. So again, making sure we understand that it's used to write really large and small numbers is one of our ICANN, and interpreting what it looks like. So scientific notation is a way of expressing, as we've just mentioned, numbers that are too big or too small to conveniently write in decimal form. Like the ones in that last notes, when we have 31 zeros behind it or in front of a really small number, that is super ugly to write. And especially when you are looking in your science classes at writing large and small numbers. This one isn't too bad, but writing it with the first number always between 1 and 10, not including 10, this is always going to be an integer, which means it can't be a fraction or a decimal. It's going to be like -2, -1, 0, 1, 2, 3. Could it be 0? What's anything to the 0 power? 1. Some of you missed that on the quiz. So if you don't have a calculation and technology, like your phones, a lot of you have calculators on your phone, and if you turn it the one way, you can see the much bigger scientific calculator than just the normal one. You have computers and your calculators. To use our scientific, but it is often very different depending on how it's working. Ms. Krenz and I were just talking about this. She was talking when she was in her high school classes that people don't understand what different technology looks like. So it automatically will put numbers in scientific notation if they're really big or really small. If there's going to be 31 decimals or 31 zeros before the number, it's automatically going to put that. So these are some examples of ways it might look. So if I am looking at this number in scientific notation, might look with a -4. So we are going to practice a couple of these right now. We are going to put some really large and small numbers in your calculator. So what I would like you to do on your calculator, and I was multiplying these two things together, it's going to look a lot different because this can hold many more digits, right? Your calculator can usually only hold like 7 or 8 digits. So when I was looking at your calculator, someone want to tell me what they got on their calculator, what it showed, Matt? Say just a little 1.221. Okay, we're going to stop at that point. And then what did it look like? Which one of these did it look like? Did it have a times 10? To the 19. Okay? Anyone have it look different on their display than, I didn't write all the numbers that he told me. Did anyone have it look with an E19? E positive 19. So that's another way that it might have showed. 1.21, and it would say E instead of -19. It would say, instead of -13, it would have just said positive 19. Okay? So the key thing is, here's a way in the spreadsheet it might look. Here's another way it could look, and it says just E13. This one gives me the 1.2, and it says -99. That's trying to tell you that it is like 0 and 98 zeros. It's a super small number, right? It's so far away. It's really, really close to 0, but it's not quite there. So you just got to be careful that you're understanding those. So now we are going to be asked to compare. And I was talking with Ms. Krenz. She said you guys have been comparing already, right? So it says when comparing scientific numbers written in scientific notation, first look at their exponents. So if we are going to put these from smallest to biggest, we want to look at the exponents first. We have 3, 8, 7, 3, and 5. Okay? The larger the exponent, the larger the number. Second, if there are more than one numbers with the same exponent, we need to look at the numbers that are used in front. So when we look at our 5.2 and 4.76, if I am looking at those, which one is my smaller one if we are looking at putting them in order? We should have the 4.76 first, right? Times 10 to the third. The next one we are going to see, 5.2 times 10 to the third. My next largest one is fifth power. So I'm going to put 7.42 times 10 to the fifth. I'm looking at the last two. The eighth is the biggest. Does it matter that it's 1.9 instead of 2.9? No. You are looking at your exponents first when you are doing those. So there's one in your homework that when you look at this, I'm okay that when you are doing it, that you actually could just tell me that this is going to be, as I look at them, I might go, this is my smallest, this is 1, this is 2, right? This is my third one, this is my fourth, and this is my fifth. Could you do it like that to tell me the order? Yes, I would take that, okay? On this page, they tell us we're going to watch this video where we're comparing these. So this is where we do the multiplication and division. And as we are taking a look at this, we're going to look at the last page first of your notes, and then we're going to come back to this. So if I am looking at which one is bigger, this is my greater. This one opens to the biggest one. If I think of less than, it's going to open to the, if we are thinking about it, this one will be open to the larger number. So which number is bigger, -5 or -4? -4 is larger. So when I'm looking at this first one, I should have greater than. Here I have two -3 for exponents. So now I have to look at the number that's in front. I have 8.52. I have 1.23. I should be looking at saying the 8.52 times 10 to the -3 is greater than 1.23 to the -3, as we are looking at that. Okay? Again, if we are looking at this one, and I ask you to compare. So I know I was talking with Ms. Krenz, and we were talking about when you're comparing how many times bigger. So if I'm asking you for how many times bigger, what we are going to be taking a look at, we're going to still use those exponent rules, but what we have to do, if we are looking at this, we are going to be looking at taking 4 times, in this case, they ask us to compare the cell compared to the bacterium. So we're going to put our 3.9, that's our cell, right? So we got to put the cell first. The cell is 3.9 times 10 to the -3. Now I will have some people change this to a decimal. What would that decimal look like? 0 point, how many zeros? This -3 tells us 1, 2, 3. So this number could be put in our calculator, right? And we are dividing it by the bacterium, right? So this is cell divided by bacterium, which is 4 times 10 to the -5. That means I should have how many zeros in front of the, if I'm looking at my decimal, I should have 5, including this one. So that's 1, 2, 3, 4, 5, and the 4. Now, 2 ways of dividing this. You could put it in your calculator. Please right now take 3.9 on your calculator and divide it by 4. 3.9 divided by 4 comes out to be about round it, about what? About 1. Oh, exponent rules. This is just like we just did on your quiz. What do I do when I subtract and if I'm dividing and I have the same base? I want to take -3 and minus a -5. What happens when you take -3 minus a -5? Put that in your calculator. That adds to 10 to the what power? -3 minus a -5 should give us 10 to the, hopefully you got second, not -8, right? This minus a negative becomes a plus. Someone said, oh, could I switch these around and put 10 to the 5th up here and put 10 to the 3rd here and subtract 5 minus 3? Yes. So the question is about how many times larger is it if we are looking at this answer? A lot of times to say 1 times 10 to the 2nd isn't a great way of saying it. So we might say it's about 100 times larger. Okay? We are going to go back in your notes to the page before, but I'm going to give you a chance to fill this in.
We can see that this one is larger because it has more places. But approximately how much larger is it? How can we make a quick estimate of
Get this a little bigger for us.
how much larger it is? In this lesson, you will learn how to make rough comparisons of very large numbers by using scientific notation. Let's review how to write a large number in scientific notation. Here's where the decimal point actually is. Here's where we want it to get a number between 1 and 10. You count from where we want it to where it actually is. That's 8 spaces to the right. So our answer is 3.1 times 10 to the 8th. A common mistake when working with scientific notation is believing that the larger number at the beginning makes a larger overall number. Even though 6 is larger than 5, 5 times 10 to the 9th is clearly larger than 6 times 10 to the 8th. Actually, it's the power of 10 that determines which number is larger, not the number at the beginning. Here are these two numbers we started with.
So this
In fact,
is your
those are
problem right in
estimates
your
of
notes.
The population of the United States and the population of the whole world around 2011. About how many times larger
Notice
is the
in
population
your notes,
of the
they're
whole
already written in
What we're going to do is
scientific
write
notation.
these two numbers in scientific notation, but we're just going to write them as estimates. We're going to use whole numbers for the part before the multiplication sign. So instead of 3.1, we're just going to say 3. And instead of 6.9, we're going to round that to 7. Now, how much larger is 7 than 3? Well, 3 times 2 is 6. So again, just estimating, it's about twice as large.
So the key thing is, here they're asking you to estimate about, because it says about how many times. So when you look at this, you don't have to make it that hard. You don't have to put it in your calculator and divide and do a ton of stuff. You're just simply taking a look
To
at
get
it.
from 10 to the 8th to 10 to the 9th, you need to multiply by 10. So overall, we need to multiply by 2.
So write this
and
down.
also by 10 to get from the U.S. population to the world population. 2 times 10 is 20. So, roughly, the population of the whole world is about 20 times greater than.
So if you wanted, and you wanted to put this big number in your calculator and take it times 20, you should get really close to this number, right? That's what they're saying. Is it going to be exact? No. Why? Population's always changing, right? So when you're thinking about that, it doesn't have to be exact, but make sure you wrote down about 20 times
The
greater.
population of the U.S. See how scientific notation allows us to make that estimate very quickly? One more example. Here's the U.S. population again.
Again,
And
your
here's
notes.
the population of just one state in the United States, the state of Vermont. About how many times greater is the U.S. than just Vermont? Again, estimate using whole numbers, so 3 times 10 to the 8th. And then Vermont would be 6 times 10 to the 5th. Now you'll see we have a little problem here, which is that even though the U.S. is the larger one, its whole number, 3, is smaller than Vermont's whole number 6. So what we'll do to get around this is we'll actually use 2 digits rather than 1 for the US.
So you're going to kind of see how they
31
change this.
instead of 3. But then we don't need to move the decimal point as far to get it to where it really is.
So notice this is not written in scientific notation, but it's more accurate because now we're going, what do we take times 6 to get 31? We're looking at what number?
So it would become 31 times 10 to the 7th. Technically, that's not in scientific notation, but it works for the purpose that we have right here. So to get from 6 to 31, you need to multiply by about 5, because 6 times 5 is 30. To get from 10 to the 5th to 10 to the 7th, you need to multiply by 2 powers of 10. So overall, we need to multiply by 5 and 10 to the 2nd, which is 100. That means the United States as a whole is about 500 times greater than just Vermont.
Okay, so as you were looking at that, as we look at those two, we were both looking at the first one being when we took 2 times 10 or 20 times greater. 3 times 7 gives us 2. 8 times 9 is the 10 to the 1. Here they said we're going to think of it as 31 times 10 to the 7th and 6 times 10 to the 5th. What do I take times 6 to get 31? We took it times 5. 10 to the 5th to get 10 to the 7th, 10 to the 2nd. So if we are looking at it, we're looking at about 500 times. So your homework that you are looking at tonight, if you turn back to page 49 and 50. So these are some other videos. I've attached them. I'm going to just, as the class is finishing, we're going to look at the scientific notation song. These are the 2 pages that you are asked to do. Okay? So these are the 2 pages that you should be doing as you are looking at those. I am right now, like I said, I'm going to put that song one on as we are finishing the period. I need you to be quiet as you're listening, and you can be working on your homework. No, we got to get bad.
Some numbers are really big. Some numbers are really
One more reminder, all
small.
6th grade choir students to go to their advisory today. 6th grade choir will be in 6th grade advisory. Thank you.
To show extreme scientific play, scientific notation does it easily. And now I love science more than I ever did before, can't you see? Express your number so that it's more than 1, but less than 10. Take that number and multiply it by 10 to the proper exponent. 300 in the scientific notation is 3 times 10 to the power of 2. 10 to
Quiet,
the power
please.
of 2 is 100 times 3, that's 300, so there's your proof. Scientific notation uses exponents, but with the base of 10, so you don't have to write out so many zeros again. And again, and again. Take a number like 0.0023, plug it into 8 times 10 raised to the power of b, where a equals 2.3 and b is -3. You can do 1 times 10 raised to the power of -3.
So as you are looking, these are attached to the daily planner too. You can take a look at those. Make sure